Hello students, welcome to the course virtualization techniques. In this class, we are going to discuss about the syllabus of this virtualization technique of our college. And then we are going to see some of the introduction about virtualization and the topics that are covered under Unit 1. How this visualization technique syllabus is categorized. So, if you see in Unit 1, it consists of introduction part. Within that, we are going to see about architecture of virtualization, five-step process, discovery, virtualization, hardware maximization. In Unit 2, we are going to see virtualization infrastructure, which is going to build the resource pool, planning and presentation network layer, storage, host server, and then requirement reuse of management practices that are all available. And in Unit 3, we are going to discuss about OS virtualization, and Unit 4, storage virtualization, finally Unit 5, network virtualization. And these are the two textbooks you have to refer through for your content that are represented in this virtualization technique. So first is Matthew Portney Virtualization Essential from Brand, and then next one is David Marshall, and that is for Advanced Server Virtualization. Okay, now let's move on to the first unit of virtualization technique. So if you see here in this visualization technique, the index part, how it is going to be organized is, we are going to discuss about the key terms that are used in a virtualization, followed by the content that is available in the unit. So this unit covers the foundational principle of designing a virtualized environment, moving from traditional physical infrastructure to a consolidated hypervisor-driven architecture. So here is the concise structure list of topics for this unit 1. First one is introduction to virtualization, under which we are going to cover what is abstraction layer and what is the use of hypervisor, virtual machine monitor, and then the core characteristics of resource pooling, isolation, and encapsulation. So the next one is the five-step virtualization process, which is very much important, how the virtualization process is implemented. So it consists of discovery process. After discovery, we have to analyze and design. Finally, we have to select the architecture. And after selecting hardware maximization, and then managing and optimize virtualization. This is how the five-step virtualization process is organized. And next is deep dive discovery phase, which is the baseline inventory mapping and dependency auditing, and finally metric logging, CPU memory, IOPS, and then network. So next is hardware maximization, next topic, which is going to eliminate ideal overhead, resource overcommitment, dynamic reclamation, and which is known as memory ballooning. And virtual architectures, we are going to discuss two types of virtual architecture. One is type 1 bare metal architecture and type 2 hosted architecture. And next, within that type of virtual architecture, we are going to discuss about the shared storage infrastructure also, which is represented as SAN and NAS. And after that, managing the virtualization environment, what are the things that are needed? That is what listed in this last sixth topic, live overload migration, distributed resource scheduling, high availability and fault tolerance, and finally VM sprawl mitigation. This is the disadvantage for leaving the VMs unmonitored, right? So next, that and all we will discuss. Okay, the first topic, introduction to virtualization. Okay, first, what is virtualization? So in previous olden days and all, we will use a physical server for a particular application. So that will be a one-to-one mapping. But now what we are going to do, sorry, one-to-one mapping. So here I have represented as 1 to M. So it is a one-to-one mapping. One-to-one mapping. One physical server is for one application. But if you are going for virtualization, we can represent one physical hardware representation for many virtual machines, right? So that is the concept we are trying to insist here. So it is the process of creating software-based representation of something rather than the physical one. In a data center context, it decouples the operating system and application from the underlying physical hardware using a thin layer of software layer which is known as hypervisor or virtual machine monitor. Right. So if you see in this diagram, this is the traditional architecture which consists of physical hardware, and here also, so this is a separate set of physical hardware and this is a separate set of physical hardware. In the top of it, we are having the operating system, either any type of operating system, and over that we are using the application. Right. So this is an independent physical system. On the top of it, we are having an operating system and application software. And similarly, this is also another independent architecture. We are having physical server, hardware, OS, and application. So only the utilization percentage, it will be utilization percentage is 5%. Remaining 95%, the system will be idle. So what we are going that there is a trade-off between the traditional architecture towards the virtualized architecture, where same physical server hardwares are available, but it is represented as resource pooling. We cannot predict which VM is allocated to the which portion of that machine. That cannot be explicitly visible, but it is done in the software configuration. Right. So this is the physical hardware which is available. In top of it, we are having hypervisor layer, and in that top of that hypervisor layer, we are representing the applications. So there are 4 applications which are running in the same physical uh, servers which are available. Right, so that is known as aggregated efficient resources. And if you see the utilization here is 80%, where here it is only 10%, and you can run only what it is one-to-one mapping, and this is known as one-to-many mapping. So what are the key benefits of resource pooling? If you see the key benefits, so it is providing resource pooling means it is aggregating all the physical resources which are available, as example CPU, memory, IO, and then allocating them dynamically. Right, so that is what aggregating the physical resources, and based on the need, it will be allocated dynamically. And the isolation. So if you see the representation of the figure, what is known as isolation? Isolation means we are going to separate one system from another system. The one system should not interfere the operations and application of the another VM2, right? So that is known as isolation. So ensuring the distinct virtual machine do not interfere with each other, enhancing security and stability. That is known as isolation. Next comes encapsulation. This is very much important. So we have to represent the entire VM as a collection of files, because this VM, what we are going to do, we are going to create a thin software layer which is going to separate. This is what the thin software layer, which is known as hypervisor or virtual machine monitor. It is going to lie as a middle layer between your physical resource and your virtual machines, right? So, what is encapsulation here? It is a collection of files making backups and replication and migration incredibly simple. So, that is what represented here as encapsulation. We know encapsulation means something we will keep inside another, like an envelope, right? So, we will keep the content within that envelope. That is known as encapsulation. Same procedure here. So the files as well as the backing up information will be encapsulated, and for a particular VM1 that will be encapsulated and kept separately, which is isolation. Similarly, for this as encapsulation, the files and configurations are uh, kept separately, and it can be used because if you, for example, if this particular server, that is the pooled server, if it is overloaded and if you want to migrate this VM2 to another machine, then that will be helpful. This encapsulation will be helpful for that particular purpose. Migration as well as replication. If you want to replicate this machine VM2 in another one more time, then that time also we need this type of configuration of collection of files, which is known as encapsulated, which is in an encapsulated form. So next we will see few definitions of virtualization. So virtualization is an abstraction layer that breaks the grid one-to-one relationship between. So that is what I have already discussed with you. So normal traditional system physical server representation is one-to-one relationship between the software and the physical hardware by translating hardware request into software commands. It allows multiple entirely independent operating system to run concurrently on a single physical machine. So this is what virtualization, right? So it is breaking one-to-one relationship, as well as what it is doing. It is translating the hardware request into software commands that maintains to allow multiple independent operating system to run concurrently on a single physical machine. Next comes hypervisor. The hypervisor is the core engine of virtualization. It is a thin layer. Uh, Already I told you, it is a thin software layer that intercepts all resource requests made by guest operating system. So what we are representing here as guest operating system, because we are deploying this application over here, which consists of operating system and then the application. So it is also VM means it will consist of CPU, memory, as well as disk. Everything will be available, right? So that is what we are representing here. So by guest operating systems such as CPU, memory allocation, and disk, right? And translate them so that they can execute by an underlying physical layer. So it acts as both traffic cop and the allocator. So it is going to control it as well as it is going to allocate it. That is what they have indirectly represented using with a traffic cop. So next comes virtual machine. It is a tightly coupled virtual machine emulation of a physical computer. So, you should know the difference between simulation and emulation. Simulation means we are going to represent the model and we are going to design it and show it in the software itself. But emulation, it is a creation of a same model, but it is a working model. Right. So it is not but simulation is a non-working model. It is just depicting what the particular model is doing. But emulation, it will show the working of the particular model itself. That is the difference. So to the guest operating system inside it, the behaves exactly like physical hardware. It has its own motherboard, BIOS, CPU, RAM, and hard drive. That already I told you. VM means it is not as simply represented as one machine. And the machine consists of all the combination of this. Right. So that is what we are representing here as tightly coupled. That means if any one configuration is missing, so automatically that will fail the entire VM. That is what represented as tightly coupled. In reality, a VM is nothing more than a collection of configuration and data files sitting on the disk. Next comes resource pooling. So the process of gathering all physical resources, all processing cores, all RAM sticks, and all network cards across multiple servers and treating them as a single. So if you see here, all the physical resources which are available, we are treating this as a single rack of resources, right? So that is what represented here as resource pooling. And instead of assigning a physical server to a department, administrator can assign a shared pool of resources. And next comes isolation. Already I have told you there is no interference between the two VMs which are available on top of the hypervisor. Same thing is represented here as isolation. So it is a fundamental security and stability concept. If a VM crashes, catches a virus or suffer from a blue screen of death, so this blue screen of death, for example, in those who are using Microsoft Windows operating system, I think you may get this. You may gone through this error, blue screen error. Only while you switch on the system, the screen will be full of only blue. It won't show any icon or anything, and it won't show any error also. That is known as blue screen of death error. So the failure of entire contained within the specific VM. So this failure should not affect the other VM. That is what they are trying to insist here. So the hypervisor prevents the failure from leaking into other VMs running on the same hardware. And next comes encapsulation. Already I told about encapsulation because we are going to create the files as well as the configuration details as a file, and that is going to depend on the particular VM. So the right of storing an entire virtual computer, its operating system, its application, its data, and its hardware configuration settings inside just a few files. So because a server is reduced to a set of files, backing up a server becomes as simple as copying a file from one external drive to another. Right? So that is what the use of encapsulation, migrating, replication, all these types of working will use this encapsulated files. So next we are going to see some of the terms which are used in hardware maximization. So first term is over committing. That is what over provisioning. So the practice of allocating more virtual resources to VMs than the physical hardware actually processes it. So for example, if your host has 64 GB of physical RAM, an administrator might provision 8 VMs with 8 GBs. So automatically what it will do, all the 64 GBs will be fully occupied. So it will lead to overloading of the system, right? So plus an extra 4 VMs with 4 GB of RAM. So this is leading to this overcommitting, and that will automatically shut down all the systems, or the system will down immediately. So that is what the disadvantage if you are overcommitting it. Whatever available in the hardware, within that only we can able to allocate the VMs. So for example, they have given here plus an extra of VMs with 4 GB of RAM. So 8 GB, 8 VMs itself, 64 over. But if you include another 4 GB of RAMs, 4 VMs with 4 GB, where it will get the resources? It won't get the resources. Automatically the system will down, right? So the hypervisor gambles that not all VMs will depend 100% of their allocated memory at the same fraction of second. So next we will see what is memory ballooning. So it is an advanced memory reclamation technique used by hypervisor when physical RAM runs low. Right, so that is known as memory. That means the memory is overloading. That is what represented here is memory ballooning. It is get extended. The hypervisor instruct a special balloon driver installed inside a guest VM to expand that memory slot. So as this balloon inflates, it forces the guest OS to page out idle process to its own virtual disk, freeing up physical RAM for the hypervisor to give a different higher priority VMs. Right? So that is what memory ballooning. So it is the advanced memory reclamation technique used by hypervisor. How it will execute when the physical RAM runs low. What it will do, it will hypervisor will instruct with a balloon driver installed inside the guest VM to expand the memory. As this balloon inflates, it forces the guest OS to page out idle process to its own virtual disk and freeing up physical RAM for hypervisor to give a different higher priority VM. So once the available memory is allocated, it is free to use the physical RAM for the hypervisor, right? So first, while it is allocating, it will be low. So the balloon driver will manage it to expand the memory and provide it to the VM. And next comes power savings, where we are going to use the distributed power management. An automated green computing feature in a virtualized cluster. If application demand drops significantly at night, orchestration software will automatically consolidate all running VMs onto a tiny fraction of physical servers. Right? So whichever VM is working, it will make the VMs to an idle state and then gracefully power down the empty host machine to save electricity and cooling costs, right? So that is very much important in power savings because if the VMs is not in use automatically, it should be done with a smooth power schedule. And next comes, so that's all about the terms what we are represented here for hardware maximization terms. Next comes management and orchestration terms. With this, we will complete today's session, and the remaining session we will continue in the next class. So a management console application like VMware, vCenter or Microsoft System Center that connects to multiple independent hypervisor hosts and manages them as a single cohesive unit, allowing for automated resource distribution and centralized clustering feature. Next comes live migration, the process of moving a powered on fully operational VM from one physical host to another over a high-speed network fabric without interpreting the end user, right? So the process should not be, the availability of the application should not be interrupted at any cost, right? So the process of moving a powered on fully operational VM from one physical host to another physical host, right? And how it is done through the high-speed network fabric without interrupting the end user. So the hypervisor copies the active RAM content and CPU state frame by frame while the VM continue to process data. Next comes high availability, a reactive failover feature. If a physical host hardware component catches fire or loses power, the centralized orchestration system immediately detects the host is dead, locates its VM files on the shared storage, and reboot those VMs on a surviving host in the cluster. Right, so that is what high availability. If it detects any failover of a particular VM, the same VM should be replicated in a different replicated as a different VM, and it should be rebooted to provide high availability at 24 bar 7. Right? So that is whatever VM that are available. So we can scale up and scale down the VMs, right? Based on the requirement, we can able to scale up and scale down. Whenever there is a high need, VMs will be more. Whenever there is a low need, then the VMs has to be, as I said earlier, it has to be power shutdown smoothly, right? And then this is known as high availability. If there is any failover also, it should not, there should be a fault tolerance and it has to make over the VM to as a another node. So next comes fault tolerance. So it is a proactive zero downtime protection feature. So the hypervisor creates an creates an exact live clone of a primary VM on a second physical host. right? So if the primary VM goes down, automatically the second it will whatever clone it is created in the another second physical host will take over, right? So that is what represented here as zero downtime production feature. So this is also dependent on the availability. And using a lockstep technology, every instruction executed on the primary VM is executed simultaneously on the secondary VM. If the primary host fails, the secondary takes over instantly without a single dropped network ping. Right? So that is what represented here. And next comes distributed resource scheduling. So an automated algorithm load balancer for a compute resources. If a specific host becomes overloaded, so this is for overload. If it is overloaded, automatically what it has to do, it has to distribute the schedule to whichever node is free, right? So that is what given here. Because an application running on it suddenly experience massive traffic spike, DRS automatically initiate a live migration to move the other VMs of that host to the server where it is clustered. And last term, VM sprawl, right? So this is very much important, which is the disadvantage that is caused only in the virtualized environment. So it is a major administrative hazard unique to virtualized environment because creating a new server takes less than a minute. But if you have left the VM unmonitored, automatically that will lead to wastage of resources as well as wastage of center capacity, right? So that is what, because creating a new server is less than a minute and it requires no hardware purchase. Administrator frequently create temporary servers for a testing purpose and then they forget to delete them. These abandoned VMs quietly continue to consume physical CPU, RAM, and its licensing cost, wasting the data center capacity. Right. So next class we will start with the 5-step virtualization process. So with this, let me close today's session. Have a great day.